on Thursday. Today we are doing sine and tangent. So first we're going to write down the formulas on your flip chart. You should have on your sum and difference tab, you have the two formulas for cosine already. And these are the final four formulas that we're writing on that tab. Make sure you carefully write them down, get your signs accurate. So here are the formulas for sine and tangent. So here is our first example. So this is going to be extremely similar to what we were doing Thursday, just different formulas. For each of the examples that I put up here, I have a second slide with similar questions, so you guys just tell me if we need the second slide or not. So we have negative 15 degrees. We need two angles that either add or subtract to negative 15. Now it is completely up to you how you do this. Some people, if I want two things that subtract to negative 15, could you come up with something? About like 30 minus 45. So we could do it that way. If you don't like the negative, you can always add 360 and get a positive and do the coterminal. Either way is fine. You just have to have two things that do work. So let's say I did 30 minus 45. So my A is my 30, my B is my 45. And if you wanted to do it a different way, you certainly could. So the formula, since I'm doing a subtraction, look at your sine difference formula. It's sine of the first, cosine of the second, minus cosine of the first, sine of the second. You do not have to memorize any of these formulas. They are all given to you on your formula sheet. So sine of 30, so your hand trick. Hold in your 30, that's your index finger. You have one finger above, so radical 1 over 2 is 1/2. Cosine 45, so if I fold in my middle finger, I have 2 below, so radical 2 over 2. Minus cosine of 30, radical 3 over 2. Sine of 45, radical 2 over 2. So we get radical 2 over 4 minus radical 6 over 4. You can certainly write those as a single fraction if you prefer. Either option is fine. B, 13 pi over 12. What should I do with that one? Yeah, let's change that to degrees. It seems to be a lot easier to work with. So we will multiply by 180 over pi. So that gives me the tangent of 195 degrees. Okay, two angles that add or subtract to 195. $135 degrees plus 60 degrees, that would work. That's not the only option. You could do 150 plus 45 would work, or you could subtract some. So you just have to find one combination. So we are looking for the tangent sum formula. So that's tangent of the first plus tangent of the second over 1 minus tangent of the first tangent of the second. 135 is in what quadrant? Reference angle, 180 minus 135 is 45. In the second quadrant is tangent positive or negative. And tangent of 45, remember tangent is square root of the top over square root of the bottom. So radical 2 over radical 2 is 1. Plus Tangent of 60 is radical 3 over 1 minus tangent of 135 is negative 1. Tangent of 60 is radical 3. In general, on these tangent problems, I am going to allow you to leave your answer like this. So I am not going to make you get the radical off the denominator. However, I do think one of the homework questions is a matching question and you do have to get it off for that one. So I will accept this, and that is perfectly okay. If I asked you to get the radical off, what would you have to multiply by? The conjugate of the denominator. So we'll multiply by 1 minus radical 3 on top and bottom. So if I FOIL that, I get negative 1 plus radical 3 plus radical 3 is 2 radical 3 minus radical 3 squared is just 3. On the bottom we get 1 minus 3. So negative 4 plus 2 radical 3 over negative 2, or 2 minus radical 3. So for this section, I am more worried that you can use the formula than if you get your radicals off the denominator. So I'll accept either answer. Any questions there? C. Tangent of 100 degrees minus the tangent of 70 degrees over 1 plus tangent of 100 tangent of 70. What is that? It's the tangent difference formula, isn't it? So this would turn into tangent of 100 degrees minus 70 degrees if I use the left-hand side of the formula. So tangent of 30. So tangent square root of the top over square root of the bottom, so 1 over radical 3, which gives us radical 3 over 3. Do we need more like these? Same thing as Friday, just plugging it into a different formula. Alright, let's do these problems. So next example I want to do is kind of similar to that 43 and 47 from today's homework. Oh, it's not that bad, Josh. Write them as a function, single function involving theta. So, sine of 120 degrees plus theta. So which formula am I using? Sine of A plus B. So my A is my 120, my B is my theta. So it's sine of 120 degrees cosine of theta plus cosine of 120 degrees sine of theta. What quadrant is 120 in? Reference angle 180 minus 120 is 60. And quadrant 2 is sine positive or negative? Positive. Sine of 60? Radical 3 over 2. Times cosine theta, we don't know. Plus cosine of 120. In quadrant 2, cosine is negative. Cosine of 60 is 1/2 sine of theta. So if you need to review that hand trick, or however you were evaluating those back in chapters 2 and 3, So that's really all we could do. We could change this if we wanted, like rec 302 cosine theta minus 1/2 sine theta. But that's really about it. That's our simplified answer. B. Tangent of theta plus 3 pi. So it's the tangent sum formula. So tangent of the first plus tangent of the second over 1 minus tangent of the first tangent of the second. Where's 3 pi? Yeah, if you subtract 2 pi, it's the same as pi. So point -1, 0. Tangent is y over x, so 0 over -1 is 0. So tangent theta plus 0 is just tangent theta over 1 minus 0 is just 1. So this just turns into tangent theta. One more. Sine of theta minus 270 degrees. So this is the sine difference formula. So sine of the first, cosine of the second, minus cosine of the first, sine of the second. Okay, 270, we know it's here, that's the point 0, -1. Cosine is the x value, so cosine 270 is 0. Sine of 270 is -1. So I get 0 minus negative, so plus cosine theta. So that simplifies to cosine theta. So this is just practicing using those formulas, except there are some points off the unit circle that we can evaluate. Do we need more problems like that? One last type of example, just a proof. So let's do a proof. We've done a lot of these this chapter. Which side would you box in?
Right.
So on the left, we're going to use our formulas. So tangent of pi over 4 plus t. So that's the tangent sum formula. So tangent of the first plus tangent of the second over 1 minus tangent of the first tangent of the second. Plus, this is the tangent difference formula. So tangent pi of the first minus tangent of the second over 1 plus tangent of the first tangent of the second. Okay, pi over 4 is like 45 degrees. What's the tangent of 45 degrees? 1. So every tangent of pi over 4 I can change into a 1. 1 times tangent of t is just tangent of t. If I want to add or subtract fractions, what do we need? Common denominator. What am I going to multiply the first one by? And the second one? So if we start foiling, I get 1 plus tangent t plus tangent t is 2 tangent t. Tangent t times tangent t is tangent squared t. On the bottom we get 1 minus tangent squared t. For here I get 1 minus 2 tangent of t plus tangent squared t. Or 1 minus tangent squared t. Right, we are getting close. The denominators match, so we can put these together. When I add, 1 plus 1 is 2. 2 tangent t and negative 2 tangent t drop. Tangent squared plus tangent squared is 2 tangent squared t. So look at our goal. Look at where we're heading to. We have the denominator. The top, I want a 2 secant squared. Okay. If you pull out the 2, you're left with 1 plus tangent squared t. And what is 1 plus tangent squared? Any questions here? I'd like to just give you the rest of the time to work on homework and ask questions when you come to them.